When we did the distributed property with difference of squares and perfect squares trinomial, remember we had this rule that if you had a plus b squared, that was the same thing as a squared plus twice ab plus b squared. So where a and b were, a was the first term, b was the second term. Now the subtraction looked very similar. So a minus b squared was equal to a squared minus 2ab, and then we still had plus b squared because negative b times negative b is positive b squared. Now the difference of squared looked like this. If you had a plus b times a minus b, this was equal to a squared minus b squared because the two middle terms dropped out. Plus ab minus ab canceled out. So now we're going to look at these and see if we can go backwards and write the factored form. This is the factored form. This is the standard form. So example 1, what I want to do is every time you do these, what you want to do is see if you can factor out a greatest common factor. So is there a number that you can divide these two, a number or an expression that you can divide these two by? So what I'm going to do is I'm going to divide them both by 2 because that's the greatest common factor of each of them. So I'm going to take out a 2 on the outside, and I'm left with 4f squared minus 25. So what's left is what's called the difference of squares. I could take the square root of this expression and get 2f, and I could take the square root of 25 and get 5. So essentially, a is equal to 2f, because 2f times 2f is 4f squared, and b is equal to 5. So I'm going to use this formula up here to factor it out. I already have my a plus b. I need to keep the greatest common factor 2 on the outside the entire time. So I'm going to have a 2. And then a is 2f, so a plus b is 2f plus 5. And a minus b is 2f minus 5. And there's my answer. And I could FOIL it to prove. If I FOILed it, I would FOIL these two and then I could multiply it by 2. Or I could multiply these two to the distributive property and then FOIL that expression, which is a binomial, times this binomial. Okay, number 2 over here. First thing I want to do is factor out by greatest common factor. So I'm noticing that I could divide both of these by a 7. Then I have 4k squared minus 1. Now what's left is difference of squares again. So it's going to use this formula. So a is the square root of 4k squared. So a is 2k. And b is the square root of 1, which is 1. So I still keep the 7 out, and I do 2k plus 1, 2k minus 1. And then number 3, still difference of squares. See if there's a greatest common factor. So is there anything that you can take out of 36 and 49? Nope, you can divide. Nope, there's no greatest common factor. Same with v squared and w squared, nothing. So I'm going to put nothing on the outside. And a is the square root of 36v squared, so that's 6v. B is the square root of 49w squared, which is 7w. So it's going to be 6v plus 7w and 6v minus 7w.